Our solar system orbits the center of the Milky Way at roughly 514,000 miles per hour, an unfathomable speed by earthly standards. Yet the Milky Way galaxy itself is not drifting aimlessly through the void. It is hurtling through space at an astonishing 1.3 million miles per hour, carrying everything we know toward a specific hidden coordinate in the southern sky. This relentless trajectory is not unique to our galactic home. Thousands of neighboring galaxies are caught in the exact same cosmic current, a massive river of stars flowing toward a singular, unseen destination. We investigate a profound cosmic mystery that has baffled astronomers for decades, a gravitational anomaly of such staggering proportions that it dictates the movement of our entire local universe. The destination of this galactic migration is known as the Great Attractor. It is a region of space located approximately 150 to 250 million light-years away, exerting a gravitational pull so immense that it warps the fabric of our cosmic neighborhood. The sheer scale of this force defies simple explanation. To move millions of galaxies at such phenomenal velocities requires a concentration of mass equivalent to tens of thousands of Milky Ways. Yet when telescopes first pointed toward this sector of the sky to behold the Titan reeling us in, they were met with an impenetrable wall. The anomaly remained hidden, locked behind one of the most frustrating barriers in modern astronomy. The realization that we were falling toward something unseen emerged in the late 1970s and early 1980s. Astronomers measuring the cosmic microwave background, the residual heat of the Big Bang, noticed a distinct dipole pattern. One side of the sky was slightly warmer, and the opposite side slightly cooler. This temperature variation was a Doppler shift, a clear indication that our galaxy was moving rapidly relative to the background radiation of the universe itself. As researchers mapped the velocities of surrounding galaxies, they confirmed a synchronized flow. The data painted a picture of a massive gravitational focal point, but visual confirmation proved impossible. The Great Attractor lies precisely behind the Zone of Avoidance. This is the dense, central plane of the Milky Way galaxy, a chaotic band choked with interstellar dust, gas, and billions of blazing stars. Trying to observe the distant universe through this region is akin to looking for a faint flashlight through a raging blizzard. The optical light from background galaxies is absorbed and scattered by the intervening dust, rendering traditional telescopes completely blind to whatever lies beyond. For years, the source of the immense gravitational pull remained a ghost, its presence known only by the profound effect it had on everything around it. To pierce this veil, scientists had to abandon the visible spectrum. They turned to radio and infrared astronomy, utilizing wavelengths capable of slipping through the dense cosmic dust unhindered. By measuring the redshift of radio waves emitted by neutral hydrogen gas in distant galaxies, researchers began to construct a three-dimensional map of the hidden space behind the Zone of Avoidance. Slowly, the structural contours of the anomaly began to take shape. The data revealed not a single supermassive object, but a complex, dense archipelago of galaxies. At the heart of this newly mapped region, astronomers discovered the Norma cluster. Located near the center of the Great Attractor, this colossal gathering contains thousands of galaxies, its mass exerting a formidable gravitational influence. For a brief period, it seemed the mystery was solved. The Norma cluster appeared to be the anchor pulling our local universe toward it. However, as redshift surveys became more sophisticated and deeper regions of space were mapped, a troubling discrepancy emerged in the calculations. The mass of the Norma cluster, while staggering, was simply not enough. Even when combined with other nearby galaxy clusters identified in the infrared surveys, the total observable mass could only account for a fraction of the gravitational pull required to drag the Milky Way and its neighbors at their observed velocities. The math did not align. The visible matter, the glowing stars and swirling gas, was insufficient to explain the anomaly. The investigation had to look beyond what could be seen, pointing toward a much darker, invisible architect. This mass deficit brought the implications of dark matter to the forefront of the investigation. Dark matter is a theoretical, invisible substance thought to make up roughly 85% of the matter in the universe. It does not emit, absorb, or reflect light, interacting with the observable world almost entirely through gravity. The Great Attractor is now understood not just as a collection of visible galaxies, but as a monumental concentration of dark matter. The galaxies we can finally detect through the Zone of Avoidance are merely the glowing foam on the crest of a massive, invisible wave. Further mapping of this dark matter and visible galaxy distribution revealed an even grander universal structure. In 2014, astronomers realized that the Milky Way, the Great Attractor, and over 100,000 other galaxies are all interconnected components of a singular, sprawling supercluster named Laniakea. Translated from Hawaiian as immense heaven, Laniakea represents our cosmic continent. Within this vast web, the Great Attractor is not an isolated object, but the dense gravitational valley toward which all the galactic rivers in our supercluster are flowing. Yet the gravitational anomaly deepens further. Beyond Laniakea lies the Shapley supercluster, a concentration of mass even larger and denser than our own. Recent studies suggest that while the Great Attractor is pulling us inward, the Shapley supercluster is simultaneously pulling both us and the Great Attractor toward it. The cosmic current is vastly more complex than a single point of attraction. We are caught in a gravitational tug-of-war spanning hundreds of millions of light-years, a dynamic interplay of invisible forces shaping the very architecture of the cosmos. Understanding these massive structures fundamentally alters our perception of our place in the void. We are not static observers in a uniform universe, but active participants in a colossal, ongoing cosmic migration. The forces driving this movement are ancient and relentless, dictated by an architecture woven primarily from dark matter. The investigation into our galactic trajectory has transformed a terrifying unknown into a profound revelation about the interconnected nature of reality. Every star we see, every galaxy we map, is a single thread in a cosmic web of unimaginable scale. Despite these monumental discoveries, the Great Attractor retains its enigmatic aura. The exact distribution of dark matter within its core remains a subject of intense study and debate. Because the Zone of Avoidance still severely limits our optical observations, our maps of this region are inherently incomplete, assembled from radio waves and infrared echoes. We are charting a continent shrouded in perpetual fog, piecing together its geography from the ripples it creates in the surrounding ocean. The full nature of the mass hidden behind our galactic center is a puzzle that continues to challenge the limits of modern astrophysics. The journey toward the Great Attractor is a testament to the relentless human drive to understand the unknown. From the initial, baffling discovery of our galaxy's anomalous velocity, through the ingenious use of non-visible light to peer through the galactic dust, to the profound realization of dark matter's dominant role, the investigation has continuously reshaped our cosmic model. We are racing toward a destination we cannot fully see, propelled by forces we are only beginning to comprehend. The anomaly stands not just as a gravitational focal point, but as a towering monument to the deep, unseen structures that bind the universe together.